Yeah.
Because I do need to get started, unfortunately. So sure it's going. Yes, it is. All right. So I'm not really sure where Jess is, but we're going to have to just get going, unfortunately. Today, first of all, if we had anyone here who is new, I would go through the slides a little bit more. But seeing as how we just have just the two of you, and you've both been here for all the sessions, so I won't spend too much time on that. Very quickly, we will just go over the little bits of the microbit again. So I shall just unplug it first of all. Yeah, there we go. Okay. So as I'm sure you're already aware because you've been using them yourself as well. So we have our A and B buttons here and here. We have our 5x5 LED screen.
Yep.
And we have our little pins down here that we connect things to if we wanted to use electricity and those sorts of things. Then we have our USB port up here. And we have our reset button just in the back here, and this guy, which is our battery. So if we wanted to connect it to a separate battery to have it connected to some little things, you can connect that one there. And then we have some other little bits like our processor and our compass, and we have an accelerometer, which is just a little tiny little square just down there. We don't have to worry too much about that one. What's more important is that we know that it's there, so we know that we can use it, because the accelerometer is the main sort of little extra feature that we're going to be looking at today and learning how to use. Specifically, how we're going to use it in terms of when it's shaken, that sort of thing. So, let me just double check my layout plan here for a moment. Where have I put it down? There it is. Okay, yeah, so we all know where all the bits of the microbit are. I say it as if I'm talking to a huge class of people, but that's okay. I'll just pretend that I am anyway. Okay, so quickly, we're going to jump onto, I'll just start sharing my screen. We'll just share the whole thing. It's easier than anything else. And we'll jump over onto, oops, that's the emulator over here. Okay, so what we're going to make today is we are going to make a magic 8-ball. So that might sound a bit weird. I'm going to just quickly grab the code that we need from over here and pop it in. Don't worry too much about what I'm doing just now. I'm just going to show you how this works very quickly. Once again, I meant to leave the same program on there. Before I switch it over, I'll just show you. This is the program that we were doing later on if we had a chance to, which is the clock. So if you can see, oh, it's actually, it's the right way up. So it's kind of a little bit tricky to see because I think it's mirrored as well. But this one's what we're going to do later on today. So as you can see, it's every second. It's the little line of dots is just moving around, not perfectly straight, but that's okay. So there's 12 ticks in all. And then it reaches the top again, and then it goes back around. It just goes in a little loop like that, but we'll look more at that later on if we get time to. Otherwise, we'll do it tomorrow. Okay, so now I'm just going to pop this over into my microbit. It's flashing for me. It's loading up. And then when it's ready to go, what's going to happen? So you can see, it's a bit hard to see because it's very blurry, unfortunately, on my screen. It's got little 8 up there, so it's kind of like an actual magic 8-ball. And now if I shake it, it'll say, I don't know. It's kind of hard to read that. So again, I think it's mirrored. That's what it's saying. Then it'll go back to 8, and if I shake it again, it'll say something different. It'll say yes. So it'll give me, every time I shake it, it'll give me a random choice from a list of string options that I've already written in there manually. Let's get rid of all that now. All right. So taking one step back, first of all, we need to think about what it is that we're actually, using today, first of all, which is the accelerometer. So the microbit actually has a bunch of built-in gestures that it can detect. Those are basically pre-programmed movements that can be detected by the accelerometer, and then using those gestures, the microbit can detect whether it's like moving up and down, if it's face up or face down, if it's been dropped, or when I'm shaking it, like I showed you before. So we, in that way, as I said before, we can detect if the microbit's being shaken with some code that I'm about to put down now. First of all, I'll just do my little import from microbit, that thing. So from microbit, we're going to import everything, which as we learned before, basically just means I'm importing all the functions and features that come to the microbit so that I know I can absolutely refer to different bits of a microbit and those sorts of things. So now what I'm going to do is I'm going to put in the code that'll help me figure out if it's actually shaking or not. So if accelerometer, it's very hard to spell accelerometer. Is that how I spelled it? Did I spell it right? Yes, I did. So basically automatically telling our program that I'm specifically referring to the accelerometer part of our microbit. So before how we were talking about how we had, if we'll have the display showing things and those sorts of things, this time we're talking about the accelerometer part of it. .was_gesture. So we're telling it we're looking for a very particular gesture. And if the gesture that I'm about to tell it, if that gesture occurs, then something else needs to happen. So was gesture, and the gesture that we're going to look for is shake. Now that is something that the microbit will already know how to read because it's one of the pre-programmed gestures, and there's a whole list of other pre-programmed gestures, like I was saying before, but the specific way to phrase that's the sort of thing that you can look up online or have a bit of an experiment with later on. So we now need to tell it, okay, if that thing happens, so if the accelerometer has registered the gesture of shaking, so if it's shaking, then we want to do something. So I'm just going to put that in the comment for now so that we know that something else can fill in there. So that might just be a matter of saying, I just want to say, all right, display.show, display.scroll. Maybe I'm just going to scroll the text of wow across the screen. And so now if I'm just going to quickly give this a name, we'll call it shake test, like that. So now I'll download that one and we'll just pop that one into my microbit. So once again, just to really revise how to get all this code onto our project, I've given it a name up here. I've come over here and hit download. So it's saved a .hex file into my downloads directory. I know my downloads directory is just my downloads folder up here. So if I find shake_test.hex, and I can find my microbit, which is down here somewhere, I can just copy and paste it or drag or drop it anywhere into the microbit folder. And then it'll automatically start copying, which I can tell because my light's flashing on the back. And now, once it's finished loading, so right now nothing's happening because I haven't told it to start showing anything as soon as it starts. But if I shake it, then, oopsie daisy, I think I've forgotten something. I did. So the problem is right now, it is only checking for if that accelerometer shakes as soon as it starts. It's never looking for it again. So if I put in here a while true, so basically if I put in a forever loop of some kind, that means that as long as the microbit is plugged in and processing, it'll always be checking for it. So we'll try that again. I'll download it. I'm now looking for that file. Back over in downloads. My bad, that's a bit of a silly mistake to make. All right. And it's copying across. You can tell because the light's flashing on the back. And there we go. So nothing's going to happen right now. But again, start shaking. And there we go. Wow. And no matter, because it's plugged in, no matter when I actually start shaking it, it'll always say wow. And if I just kept shaking it over and over and over again, then it'll say wow, and then it'll just say wow again, straight away. There we go. So really, really simple process to actually get that accelerometer sort of registering things. But we're gonna now move on to actually making our Magic 8 Ball now that we understand how that works and how it's all put together. So I've already got my from microbit import thing. So I should actually have a comment up here saying I need to import my libraries that I need. And down here, I'm going to actually just get rid of this code from down here now because we'll put it back in again later. We have some more important things to add in first of all. So the thing about the Magic 8 Ball, as I'm sure we know, because I'm sure we've all used Magic 8 Balls before, is that they'll always give you a random answer from a bunch of pre-made ones. So whether you have a physical one, which has one of those little cool like dice things inside, that when you shake it, it'll just roll over to a new face, or even just a digital one, you'll always get a random answer from a list of predetermined answers. So because we want to be able to give a random option, we're going to use a library that I think we used at the end of last time, which is random. We're going to just import the random library, just like that. So, yeah. So now what we need to do is now we need to actually define the list of potential options that our, for the answers that our Magic 8 Ball can choose from. So for that one, remembering to define a list, what we're doing is we're basically just defining a variable that will store a whole bunch of different kinds of information in. So it's just like writing out a variable. I'm going to give it a name, equals, and now to tell it that it's a list, I'm going to put it in square brackets like this. So I've now told it, all right, there's going to be a whole bunch of different options stored inside answers. That's a list. Oh, and we have Jess by the looks of things. I'll just pause for a moment and see her. Can I make this bigger? I can't, that's all right. Hello, Jess, can you hear me?
Hello. Yeah, I can. How are you?
Excellent, I'm well, thank you. Yourself?
I'm good, thanks.
Great. I'm not sure if you've been hearing any of what I've just been talking about.
No, I've literally just arrived.
Oh, no, that's totally fine. What I can do is I can just quickly just recount the stuff that I've just gone through. So basically what we're doing first of all today is we're making a Magic 8 Ball using our microbits. So I've already got rid of the program on here, unfortunately. Basically what we're going to be using is learning how to use the accelerometer function on here. So the accelerometer, basically it will sense different kinds of gestures and things. So it can sense like whether the microbit has been moved up or down, or if it's face up or face down, or if it's fallen, or if it's being shaken, and a few other little things like that. But that's the basic gist of things. Now, the way to actually, first of all, tell it that we're talking about the accelerometer. I'm just going to get rid of this stuff up here. We'll come back to that. So first of all, we need to tell it we're talking about a microbit. So we're going to import all of the features from a microbit. And now what I'm going to do is I'm going to say while true. So basically forever, as long as this process, as the microbit is turned on, you need to be looking for this. We're going to say if accelerometer. So basically straight away telling our microbit, all right, we're specifically looking at the accelerometer function of your microbit. We aren't worrying about the display. We aren't worrying about any of that stuff. We're just looking at the accelerometer. If the accelerometer dot was gesture, so saying, all right, you're looking for a particular kind of gesture to do with the accelerometer, and the gesture we're looking for is shake. So that basically just tells it, all right, so as soon as you see the accelerometer, as soon as the accelerometer, can't speak, sorry. As soon as the accelerometer is taken, we know something needs to happen. And in this case, all that's going to happen is we're going to, on the display, we're going to just scroll the text of wow. So it knows that that's, so we can see that it actually has register the shake. So that's the exact same program that I have on here now. I'll just make my screen a little bit bigger. So that's the program that I have in my microbit at the moment, and it is turned on. So right now, nothing's on the screen because I haven't told anything to be on the screen. But if I shake it, and we have wow, scroll across the screen. I'm not sure if you can see that, unfortunately, but yeah, it'll scroll across the screen for me, like that. All right, so now that was a quick 2-minute summary of what I've just covered before. So we'll get rid of this code. We're going to use a similar code to this, but we'll use it in just a little bit. For now, I'll just go through. So Magic 8 Ball, as we know, gives you, when you shake it, it gives you a random choice from a predetermined selection of options. I think Jess's internet's just frozen. I'll just wait for her to pop back.
Do you want to mute us?
Yes, I might now. So I left it unmuted before because it was just you, but now that we've got more than one, I'll mute you guys again. I think we might have lost Jess because yeah, her that's disappointing. All right, we'll just wait for. Oh no, this is pretty easy to catch up with, so I'll just quickly go back to where we were up to. So yeah, we're going to import random, the random thing, and we're going to have a list of answers like that. All right, so now we need to actually tell it what our, and yeah, she's gone. I'm sure she'll be back in just a moment. So first we need to tell it what our various answers are that we could possibly have from our Magic 8 Ball. And this is the bit where, you know, if you have students, it's a great place where they can sort of go ahead and make it their own and make it, you know, add their own little personality into it, but we're going to keep it pretty simple right now. So our options, let's say I'm going to have an option which is yes, and now to determine that it's a different potential option, every option needs to be in its own set of inverted commas like that, and then you have a comma between each option. And to make things a little bit easier visually, you might want to have every option on a different line like this. But at the same time, if you only have a few options, like I might only do 2 or 3 for now. So we've just got yes, no, maybe, and I might put in, I don't know. You could have in more than that if you wanted. Like I've got some down here that are like, could you repeat the question? But the thing to remember with microbits, especially if you're in a bit of a hurry to teach or if you've got a lot of students, is that the microbit, because you have to display the text scrolling across the screen, the longer the bit of text is that's coming across the screen, the longer it's going to take for you to actually be able to see the entire thing. So for example, when I was experimenting with the program before and I had, could you repeat the question? That was great and everything as a longer answer as an option, but the problem was that it takes like 15 seconds for the entire answer to come across the screen. So it just can make it a little bit tedious sometimes. So if you wanted to keep it relatively short, then that's totally up to you. It can just make things a little bit easier, especially for teaching purposes as well. So we've got our list of answers. So now those are our potential options. And now we actually need to create our game. So we're going to start by displaying an 8 on the screen, just like the real Magic 8 Ball like we had before. So again, because we want the 8 to be displaying pretty much whenever there isn't anything else happening on the screen. So because of that, we're going to have while true, so inside what is essentially a forever loop, so it's happening whenever the game is running. We're going to have display.show 8. The reason why we're going to use show instead of scroll is just because 8, it's just one character. One character can fit on a 5x5 screen quite easily. When you have more than one character, that's when you're going to have to use a scroll because you can't see everything at once. If you just have one character or so, then generally a show is fine. That means it'll just stay on the screen. Nothing will change. So we have our 8 showing up. Now we need to check and see if the microbit is actually shaking. So that's just the exact same code that we were using before. So if accelerometer.wasGesture shake, and again, so just checking to see if the accelerometer has registered that the microbit is shaking. And I'm pretty sure this is one of those things where it's case sensitive, so I think it would have to use all lowercase, I'm pretty sure. Because again, if you didn't, then it might think you're talking about a different kind of gesture and it might not really be sure what it is you're talking about. So if it's shaking, then we need to do something. So I have a little check and see. I'm not really sure what happened with Jess before, unfortunately. Disappointing. Oh well. All right, I'll just pause there for a moment. What I might do is I might download this to my microbit for now, just so I can see what's happening. Sorry, I'll put it back just a moment. Here we go. More chat. So with the knowing when to use uppercase or lowercase, generally it's a rule of thumb is basically if you're talking about a specific function to do with the microbit or in Python or anything like that, where you're using something that has been pre-programmed. So you're referencing something that that has been pre-programmed, basically, that you might have imported from a library, that sort of thing. That's when you generally need to make sure that it's case sensitive. The easiest time to use non-case sensitive stuff, so when you know you can use whatever uppercase, lowercase you want, is when you're referencing something that you yourself are doing. So for example, up here, for example, when I'm writing this stuff, I know it doesn't really matter if I have a lowercase y or an uppercase y. All I'm doing is just displaying text that I've told. In general, in terms of knowing specific situations about, I know that in this situation it needs to be lowercase, in this situation it needs to be uppercase. In general, in Python, most pre-programmed functionality will be in lowercase. It's actually quite rare in Python to find things that have uppercase. Generally, that'll be in things that will, I mean, I'm sort of talking from experience as opposed to actual, I know this for a fact. But from my experience, if something has has an uppercase letter in it, that generally means it's something which is a very kind of high up functionality. So it's something which will have general, like in a hierarchy sense, it'll have priority over everything else. So for example, the true here, that has a capital T because true, as in it means that it will always be true. There's no way that true with a capital T can ever be false. And so when you're using that, that generally means you're determining that something will always be happening all the time. I'm not sure if I'm explaining this very well, sorry. But also it kind of comes down to like just from like memory as well, and remembering it, because uppercase letters are quite rare in Python in terms of when you're using them to reference predetermined functionality. It'll only be a few things here and there that'll have uppercase letters, and you'll have to use them in really specific situations. So in most situations, if you just put everything in lowercase, and then if it doesn't work, you can come back and say, oh, I see, that needs to have an uppercase letter. A lot of the time, the uppercase, lowercase stuff, while it'll give you an error if you use it wrong, it'll normally give you a very like specific instructions when it comes up with the error. So I hope that's explained your question. Okay, so now we need to actually use that random library that we imported earlier to actually choose an answer. So then we can use that scroll method that we've used a bunch of times to show the answer. So we're also going to add a little short pause for some dramatic effect. So we are already sensing for if there's a shake. So there's a shake. First we'll have our dramatic pause, which is going to be sleep 1000. That's basically just a fancy way of saying wait. The microbit won't actually turn off or anything. It'll just wait for a little bit. It knows that it needs to be sort of turned on and stay where it is, but it needs to not be trying to do anything else for a while. So then we're going to display .scroll, which we've used a few times now. And now what we're going to do is we're going to reference a function from the random library. So that means we need to reference random dot, and the function from the random library that we're going to reference is choice. So random.choice. So we need to choose a random choice from what I'm about to give you. And so I could give it a range if I wanted to, but I'm going to give it the list right now. The list I'm going to give it is answers, just up here. So we can close up the random.choice. So to break this down a little bit more, basically we're telling it, all right, you need to look at the answers list that we had before. From that answers list, you need to make a random choice from the answers list. And then whatever that is that you've chosen, that needs to scroll across the screen, just like that. And that is actually all the code. So I'm going to change this name up here from Shake Test to, I'll change it to Magic 8-Ball. And then I'm going to just download it. And I'll find it again over in my downloads folder. And we'll put this one into my microbit. Wait for it to finish loading. And there we go. And there's my 8, my very hard to see 8 because of my terrible webcam. And now if I shake it, I don't know. There we go. And if I shake it again, once it finishes, it'll give me, I think it's maybe, yeah. And once again, shake it again, no. And there we go. And then I'll go back to our 8 as well. Only I just shook it again, whoops. Right. So I'm going to unmute you now. So, because considering it's just you and I,
Looks
so
like.
yeah, so I don't think Jess is coming back, unfortunately. So I might as well just leave you unmuted unless there's a huge bang in the background or something or other. So if you have any questions, just feel free to speak up. Yeah, so that's the entire Magic 8 Ball. As I said, it's a really, really simple game. The hardest part is just understanding how the accelerometer shaking thing works.
Yeah.
Do you have any questions at all about that so far?
Just like with the Sleep 1000, does the 1000 equate to 1 second, or like is it actually?
Yeah, I think the 1000. I think it's like 1,000 milliseconds or something or
Yeah.
other.
Yeah.
So
I sort of figured that probably was, but
yeah, so it's basically just 1 second.
yeah. Okay. No, that seems. It doesn't with the indentation and that.
Mm-hmm.
That doesn't really matter, or is that more just for sort of formatting to keep keep track of where you're going?
Yeah, that's actually a really good question because it is actually very important. In particular, it sort of depends on what language you're using, but because we're typing in Python, indentation is actually very important, and also depends on what kind of loop you're using as well. But the indentation, while part of it is definitely to do with just like a formatting regularity, that sort of thing, and make it easier to look at and understand what it's all doing. If, for example, I had this display.scroll, if I unindented that, what that means is that is no longer part of the if loop up here. So now what it's going to do is when it's reading the program, it'll say, all right, while true, all right, what's next? Display.show, so I need to always be displaying an 8, and then it'll go down, all right, if accelerometer if it's shaking, okay, then I'll wait for a second, and then no matter if it's shaking or not, it's going to then come down to the next one and say, I'm going to scroll a random choice of answers. So another way of thinking about that is basically it'll read down through this, because as we know, when it reads a loop, it just reads from top to bottom, from top to bottom, from top to bottom, as long as it needs to. So because display.show and display.scroll are no longer part of this loop, then what's inside this loop, for example, will only execute if the microbit is shaking. So we want to only have an answer scrolling across if the microbit is shaking. By having it outside of this loop, even if it's not shaking, the program will continue to read through it, and because that isn't part of the if loop, it'll keep scrolling it over and over and over again. So if I download this as it is now and pop this again into my microbit, hopefully this will show you what I mean. Oops, daisy. Thank goodness.
A nice long cord with yours. Mine's not working properly because it's such a short cord they provide with the microbit.
Yeah.
And it's up against the it doesn't like it. Like as soon as I try and shake, it's too short. It sort of dislodges it from the port. So it's not so good.
Yes, as you can see, even though I'm not shaking it, it's just going to keep scrolling options from answers over and over and over again. So I'm not shaking it because it's not inside that if loop.
Yeah.
So it doesn't know that it only needs to show an answer when it's shaking. It thinks it just needs to show it forever because the loop that it thinks it's inside of is just the while true up here.
Okay.
So does that answer your question?
Yeah, no, that's good. That's good.
Yeah. So yes, general rule of thumb is that the indentation is very important, which is one of the good things about this particular editor is it actually makes it a little bit easier to figure out what's actually inside and outside of different loops. So when you're looking at sub loops, so we'd consider this a sub loop because it's inside of this while true loop. This one here, you can see it's actually like, it's kind of hard to see on my screen, but there's a little gray line that comes down from underneath the I in if.
Oh, yeah.
So that basically just tells me, and now if I go into if I go into another line down here, but then if I wanted to say, all right, now I want this to be outside of the next ones, maybe instead of that one, I want to now say display dot scroll, I don't know, display dot show 12 or something or other, some other number. As you can see, that little line has actually it's only on the two lines that are inside the if loop.
Yeah.
So it's an easy way that you can look at it and you can see exactly where that loop's sort of conditions extend to, if that makes sense.
Mm-hmm.
Yes, so it just makes it a little bit easier to understand. Yeah, and if I come down here, yeah, you can see it stops there.
Yeah.
All right. So yeah, so that'll make sense. Do you have any more questions at all about this game?
No, that's good.
Awesome. So then we'll move on to our next one, which is our clock. Okay, so I'm just going to get rid of all this code. Are you happy for me to get rid of that code? You copied it all down there?
Yeah, I've been copying as I go. So
great, awesome. Whoopsie daisy. Okay, so now what we're going to do is we're going to make that clock, which is that little one that I showed at the very beginning with the little line that just sort of switches around. So we call it a clock. It's not really like a proper clock, but it sort of functions. It sort of looks a bit like a clock, so it's okay. So first of all, obviously, I need to import all my microbit functionality. So import my libraries. So from microbit, I want to import everything. All right. Now this one, I'm going to teach it in sort of two different ways if we have time. There's one way, first of all, which is very simple to understand how it works, because it's basically just a huge chunk of text and different lines of code inside of a while true loop, inside of a forever loop. But what that huge chunk is, it's basically just 2 lines of code just repeated over and over and over and over again. And then if we get time afterwards, I'll go through a slightly more advanced way of doing it, which uses a little bit more sort of traditional programming features, because we wouldn't normally recommend this way of doing a program just because it is so repetitive, and so you can use loops to sort of make it a bit less repetitive. But to start off with, we'll just understand what actually is part of it. So as I said before, what's going to happen is we're going to go into a while true loop. So forever, we're going to be cycling through the code that we're about to put down. Now what we're going to do is we're going to be displaying a whole bunch of pre-made images. If you remember from the last Teach PD, how there's some pre-made images that are like emoticons and things, how there was a pre-made like happy face and sad face and those things. What all those images for what the clock was doing was it was actually cycling through pre-made images as well, and those images were just called like clock 12, and that would have the hand, so to speak, facing directly up. And then you had clock 1, which was sort of to the side a bit. And then you have clock 2, which is a bit more to the side, and clock 3, and so on and so forth, and so on and so forth. So we're going to show that image. So to show the image, we're going to display dot show. And then to display an image, you need to reference the image function of the microbit library. Image dot, and the phrasing for this is, in all capital letters, clock. I'm going to start at 12 because we want the hand to be facing directly up when we first start. And then we're going to have sleep 1000 because we want it to be a second on each little tick, so to speak. And now what we're going to do is we're going to just grab this code. I'm going to copy that by Control C, and then you just paste until you've got it down 12 times, basically. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now I'm going to go back and change all these numbers. So I've got clock 12, and then I want 1, and then 2, 3, 4, 5, 6, 7, Stacy, 7, 8, 9, 10, and 11. Now, of course, the reason why we start on 12 is because we want it to be facing directly upwards, and we'll only go down to 11 because it's in that forever loop. So as soon as it finishes that final sleep 1000, so as soon as it's waited for that last second, all that's going to happen, it's going to see there's no more code left to go. So it's going to come straight back up to the start of the forever loop and start right back up at 12 for us again.
Right.
So I'll quickly call this one clock 1. And I'll pop this onto my bit here. And there we go. We have it ticking for us.
So there was nothing at the end of that?
No, so at the very end,
Just
I'll just go down a bit more.
Yeah.
Yeah. So there's a sleep, and then that's all it is, because when the loop sees that there's no more code to come after that, it knows that it just needs to go straight back to the beginning, basically. And it'll just keep ticking away for us as long as we leave it. I just had one quick thought, because you mentioned about how your cord is quite short. These cords, I'm just going to unplug my microbit. I'm just going to eject it first of all. There we go. These cords, they're actually those, pretty sure they were called like, I'm not sure what the exact specifications for them are, but they're called like almost considered universal cords.
Yeah.
So they're not unique to microbits by any means whatsoever. And they're ones that a lot of old smartphones, not so much the current versions of them, because they've all got, you know, capitalism, everyone wants their own kind of cord, but they're ones that were very common for smartphone chargers for a while there, especially non-Apple smartphone chargers.
I know the ones you mean.
Yeah, so if you have any cord that is like this, just lying around anywhere, it'll work exactly the same. So if you find one that's a bit longer, especially if you happen to have a smartphone.
I might look for one at home, I think.
Yeah, because, yeah, it's exactly the same. It won't break the microbit or anything. As long as it fits in that port, it'll work exactly the same way. So you won't damage the microbit or anything, and it might make life a little bit easier as well.
Yeah. Yeah, no, that's good.
Yeah. So how did you go with that code just there?
Yeah, no, that's fine. I'm not actually trying to put it through mine. Like, I'm sure it'll work.
Yeah, no worries.
I'll have to just troubleshoot. I'm just sort of making sure I try and keep up with what you're doing.
Yeah. No worries at all. All right, so as I said, that was super, super simple, and I wish I could say it was more complicated than that, but that's actually that's actually that version done. So I went through and made a slightly updated version, especially if you have people who are a little bit more advanced, and I would now consider you a little bit more advanced. So we can just get rid of all that now, and I'll show you a different way of doing it, which is it's still going to have quite a few lines of code to look at, and it actually probably has more lines of code than that version, but ultimately it'll function a bit better, especially if you decided to go back and change it last minute. So what we're going to do is sort of mash this up with the game that we made before with the Magic 8 Ball. We're going to start off, we're going to import our library, but then we're going to make a list, and we're going to put all those images into a list instead. So I'm going to call it clock faces, and I'm just going to go through really quickly. Because these aren't strings, you haven't got to put them in inverted commas. We can just say we want one that's image clock 12. And I'm going to just quickly copy just image.clock like that. And then on new lines each time, I'm just going to put in clock 1, clock 2, clock 3, clock 4, 8, 9, 10, 11, and 12. Whoopsie daisy. Whoops, I don't need clock 12. My bad. There we go. And whoops, I didn't put commas between those. Rookie error. There we go. All right. So now my list knows that these are all the things that I want to be able to reference and use. So now I can go back out over here. What we're going to do, so to reference where we are in the list, we're going to make a variable called position. And I'm going to start straight away, set my position to 0. So because as we know, when we're counting in programming and in Python in particular, we always start from 0. So if I had to tell you how many items were in this list up here, I would actually say 11, even though there's really 12. So position equals 0, so that I know that whenever I start this, I'm always going to start from the very beginning. Now, inside my while true down here, what we're going to do is we're going to straight away display.show. And instead of putting in our images here like we had before, how we had like 12 lines of display.show, then sleep, we're going to have just one single display.show, and we're going to display from our list, so display from clock faces, then in square brackets, we put in position. Now, what the square brackets do is they tell you so position, we know right now position equals 0. When I started off, position equals 0. What the square brackets do is they tell you the position of where inside the list you're referring to. So right now, I've said my position is my variable position, which is 0. So right now, what's going to display straight away as soon as I start is image.clock12 up there.
Yeah.
So then we're going to do our sleep for 1,000, sleep for a second. Nice and easy. Now all we have to do is tell it, once you've done this, you then need to go on to the next one, and then don't go any higher than the highest one. If you're at the very last item, you need to go back to the very beginning. So this isn't the most elegant way of doing this, but it does work. So what we're going to do is we're going to say position plus equals 1. All that means is basically whatever position is, you need to take that number, add 1 to it, and that's the new value position. So for right now, for example, position equals 0, so 0 plus equals 1 is 1. And then 1 plus equals 1 is 2. And then 2 plus equals 1 is 3, and so on and so forth, so on and so forth. Very, very simple. So that's how we can tell it to move on to the next image, basically. But the problem is if I leave it like that, then once it gets to the end of our list here, it's going to run out of things to go to. And the whole thing's going to just sort of get stuck in a bit of an unfortunate error. So what we need to do is we need to tell it, if you're at the end of the list, then you need to go back to the very beginning. So to do that, we're going to put it inside of an if loop. So if position is greater than or equal to 12, so basically because it's only 11, what we're saying here, so this one here, this is in position 11. Even though there's 12 items listed, it's in position 11, obviously. So we're saying, because we've already added 1 here, when we've come through this loop for the last time, position will equal 11. So it'll display clock faces 11. Sleep for 1,000, position plus equals 1. 11 plus 1 is 12. So then if position is greater than or equal to 12, so basically when it hits 12, then position then needs to equal 0 again. So it'll send it straight back to the very beginning of the loop. And now I'll download that again. Actually, I should just call it something different. I'll call it clock 2 instead. And we'll go into downloads. Here it is. Pop that one into our microbit. Now, in theory now, we shouldn't see any difference at all in the way that this functions.
Yeah.
Yeah. And we'll let it just do its thing and go all the way around to the beginning again. 7, 8, 9, 10, 11, 12. And it'll keep going like that. And there we go. So as you can see, like it still functions in the exact same way. And there probably aren't that fewer lines of code in this than there was in the other version. But it's more a matter of this way you can show some more of the slightly more advanced concepts of Python with microbit. So it isn't just essentially 2 lines of code repeated over and over and over again. It just gives you a really easy way to practice those principles and those skills that we've learned through the other programs as well, with the loops and the understanding how to break down a line like this, which has like this line here, which has so many different sort of little components to it. So understanding, all right, when I say position, I'm referring to that variable. When I'm saying clock faces, I'm referring to my list. When I say show, I'm referring to whatever function I've just defined. When I say display, I'm referring to the display on the microbit. So knowing how to break that down, which is probably one of the things that can take students the longest to wrap their heads around. Because if they see that, they're going to look at that and think, what? What do these words mean? So by taking it slowly and taking it through them step by step like that, it's amazing how you can look at that then and understand exactly what we mean.
So is with the difference between the variable and the list, just purely because you have created a list there, like with separated with commas, like if that, so position, like you've got the variable there, is it because it's numerical, the variable?
So a variable can store any kind of data. It can store a number, it can store a string. All a list is in another way of thinking of a list is it's just another kind of variable. It's just a variable that can store a few different sections of information as opposed to just a single one. But it just means that you're sort of limited in the way that you can refer to it. So, you have to refer to a specific part of the list.
Well, that's what needs,
Yeah. As opposed to being able to just say, use this thing here. But at its core, it still has the same basic principles of a variable, which is that it's a way that you can store data. And just like a variable inside of a list, you could store pretty much any kind of information. It can be a number, it can be a string, it can be like here, you can be referring to pre-made bits of stuff. It can be pretty much whatever you can think of, basically. So the only difference is obviously a variable like this, that's just what we would call an integer. So it's just a number. It's a single number. And then up here, instead, the variable is a list. So it's many different kinds.
The other question I was going to ask is, like you're saying, like these images, they're all part of the light. So where do you go to actually see exactly what's in the library? Like, how do you know? Like, you don't know what you don't know. So.
Yeah, that's a great question. I'm pretty sure generally with this sort of stuff, like Google is your friend. It's a sort of thing that realistically, the easiest way to find it is if you Google it, there's always going to be places where they have full lists of the things that you can use. This website is one that I've been looking at a lot recently, where it does sort of go through a lot of the stuff that's in. And then I'll put the link in the chat for you if you'd like.
Okay.
Just hope that's to Jess. There we go. Right. There we go. So this one, as you can see, it gives you a list of the built-in images in a microbit.
Yeah.
Some of them are more clear than others as to what they actually are, and some of them are more suited to the 5x5 than others. But yeah, this website in general is one that I found has been quite valuable to refer to for finding out those things that are pre-built in. Again, it's one of those things where unfortunately, you're probably never going to just be able to remember everything. You might remember little specific things, but ultimately, having a cheat sheet, so to speak, is always going to be the best way for remembering the important bits, basically. Yeah, as with programming in general, like with Python, because Python is such a diverse and dense language, there's so much functionality that you wouldn't remember that it even has. So that's why we always have these cheat sheets and things, and just like these sorts of things that we have with Coding Kids, which is basically just like so that because in pretty much any kind of a programming real world context, you're never really going to be expected to remember this stuff off the top of your head? So first of all, I'm sorry, am I right to close this now? Are you finished copying all this down?
Yeah, I've got all that.
Yeah, great. Okay, well, I might stop sharing my screen now. So in real world programming situations, there's kind of, especially these days, there's never really going to be a situation where you're going to be expected to remember everything off the top of your head. I know, for example, when I first went into uni, and I had my first few programming exams, we were really surprised to find that a lot of them were actually open book, or you could take in substantial notes with you, especially because of the fact that you are literally working with a computer, and pretty much everything is connected to the internet these days. There's no situation in the real world, if hypothetically, in an extreme situation, if you became a programmer, a developer of some kind, there's no situation where you aren't going to be able to just Google, what's the, how do I get this to do that? What's the pre-made function to do this in Python? Because I know there is one, but I just can't remember what it's called. So there's no point in trying to force yourself to remember all these things.
No, it's really knowing where to find them.
Exactly, yeah.
Having a bit of a feel for what things are actually there that you can just call on without having to try and create it yourself.
Yeah. So while it's really good to sort of have your own little backlog of things that you know how to use, and that's sort of the thing that it'll come inherently with doing programming, is you'll just remember some of these things, especially when you're doing something which is a bit new, or for students who are sort of brand new at it. And there's really no shame in Googling, honestly, and seeing what's available in terms of resources. And that website that I just showed you, that's a great one, because it's a website pretty much, or at least it has a section entirely dedicated to microbits. So it's pretty great in that way.
So it's a little bit aside from this. So in terms of, if, we're a primary school, so from foundation, like reception, or from 2-year-old to year 7, so, 12, 13-year-olds, is there a language that we should be focusing on? Because some will say use Python, some say use JavaScript, some say, get into the C, just start with the C# stuff and go from there. And it's, as not really a programmer, I've done a lot of ICT stuff over my time, but not real, I've messed around with logo and, the old turtle logo stuff, but not proper language, and because there's so many, there seem to be quite a few of them, what's best to target?
They're all really kind of coming out of the woodwork now, aren't they? Well, that one really comes down, there's a lot of different factors that you got to take into account, as I'm sure you're aware of. So when you're looking with younger students, so when you're looking at prep to about grade 3, sometimes grade 4, then that's when we generally recommend visual-based programming is best. So when you're looking at the really, really young starters, so prep to grade 1, even grade 2 sometimes, then and then again with 2 to about grade 4, there's this sort of package of languages offered by a company called Scratch, which I'm sure you might have heard of. You might have heard us talking about them in previous ones. It's one of the main languages that we teach with coding kids. It's the main one that I have taught before. And it's all very visual-based programming. So instead of having to type their own stuff out, everything has sort of been done for them and broken down into little blocks that all they have to do is just understand that block does that. So if I grab that and pop it over here, so that's generally really good for, sorry, I've just been told my internet connection is unstable. So if I suddenly break away, that's why. So that's really good for students who are really, really brand new with programming. When you get older than that, that's when we start recommending Python, basically, because Python, you can sort of do it in this easier way like we're doing right now, where once you sort of have the basic concepts down, everything is very straightforward, but there's still a lot of different things that you can do with it. at the same time, when you are more advanced with it, there's still a lot of much more complex, intricate things that you can go into with Python as well, depending on, what tutorials you're watching, who you're working with, what you're doing, what your kind of content is. And it's one of the reasons why I think it's been quite heavily sort of emphasized with digital technologies, I think, because it is such a diverse language that can be used with people who are brand new to programming and people who are much more advanced. So for example, it was one of the first languages that they taught us in uni in the like introductions to programming, those sorts of things.
Okay.
At the same time, if you have students who you're trying to encourage to get more into programming, but they might be struggling a little bit, or they might be a bit reluctant even. And that would be where I personally would recommend going into more like web dev, that sort of stuff, so HTML, and then bringing them into JavaScript, because HTML is one of the simplest introductions to working with computers and understanding how some part of technology works, because it's so simple. And then once you can get them interested in HTML and CSS and that sort of stuff, that's when you can start introducing JavaScript and get them into more of the programming stuff. So it really depends on like who you're working with, what kind of content you want to cover, what experience do they have, how willing are they with this, or is it something they have to do because their parents are making them do it, that sort of thing. Scratch also is a really great way for great thing for especially the younger students, because it is so visual based and everything is colorful and pretty. So even if they don't really get that interested in the programming stuff, first of all, they'll get excited because they're choosing their own characters and they can change things about their characters, and there's pretty colors and I can connect things and that sort of thing. So it's kind of a bit more of a tactile engagement as well.
So sorry, you're breaking up a little bit there.
Sorry,
seem to have come good again now. So so you're saying like suggesting like Scratch sort of the early years, that's what we want to do, and then you could look at Python. Is that right?
Yeah.
And then you're saying that as they get old, like there's JavaScript, but if they're like you could do HTML, CSS.
Yeah, so JavaScript would sort of tie into HTML and CSS because that's all web development stuff.
Yeah.
So basically Python is what we generally recommend for students who are like more advanced in grade 4 and then up. So especially if they've done coding for a very long time. So for example, students who start at the very, in like grade 2 with us and do Scratch with us for a couple of years, generally by grade 4, they're a bit more advanced. So we'll generally kind of say, hey, time to go up to Python. And then Python's really good for probably right up to about grade 7, because it is such a diverse and large language that can be used in a variety of different ways. But then for the sort of the same age bracket, so from about probably grade 5-ish upwards, especially if they aren't super confident, or if they aren't like necessarily super keen about the actual programming side of programming, or even just in general, even if they are, then web development is the other kind of content that you could encourage them towards, because the introduction stuff is so easy, and so you can get a lot more results a lot faster. So if they need that encouragement of type 3 things, see it on a website, I can program now, then that can help them out a lot. All right, my alarm's going off telling me it's time to finish up.
Yeah, that's right. Is there something like, the web editors that we've been using with the Python, is there something like that with the HTML? Like, is those sorts of things out there as well? I'm looking for, but do you know if that exists?
There absolutely should be. There's one that I'm thinking of. I'm not sure if it's specifically about web dev. I'm just going to double check. Oh, it's a bit more advanced as well. See, I can't think of one off the exact top of my head that is ideal. There's one which is, this is probably way too advanced for students, especially in the age bracket that we're talking about. There's one called Cardpen, but it's kind of more for actual developers. So I suppose it also, you know, if teachers, if they have a bit more experience with web dev and stuff and they wanted to have a bit of an experiment with that. I haven't actually taught any web dev with coding kids. So normally that's when we kind of find access to it. What I can do is I'll quickly just jump onto our staff site very quickly. Because if I go onto our web dev section, it might be like, here's the editor that we use. Web dev.
Because I haven't done anything like that with the kids.
So what we generally do is with web dev, I thought so. We generally teach them web dev on using programs they already have on their computers. So like Notepad and Notepad++.
Right.
And then on Macs they use Atom. So yeah, that is a way that you can use it. But the problem is because they're offline, you don't get as much sort of support as you do when you use online editors. But, you know, it's still a fantastic platform for experimenting. And the great thing is because it is all offline, it's a little bit kinder to you as well if you are brand new, because you aren't going to sort of get hit by, you know, suggestions of doing things that are sort of way out of your skill range.
Cool.
All right. Well, if you didn't have any more questions, we'll have to wrap it up there, I think.
That's cool. I've asked lots of questions, so thank you very much.
No worries at all.
Like a one-on-one tutorial.
It worked out very well in terms of progression, that's for sure.
No, that's very good.
So are you registered into the very last one?
Yes.
Great. So that's on Monday. I think we're doing an earthquake detector on Monday. I haven't actually looked at the content yet, but I think we're doing earthquake detector. So it's one of the big programs that we always talk about, but trying to get into. Yay.
That'd be good. I was just thinking about like what our year fours were trying to do, and something like that would have really, it's probably a bit late now, but that would have really probably piqued their interest, I think. Like it would have. So, awesome. See you Monday.
You absolutely will. I'll see you then.
No worries.
Bye.
Thanks.